we're going to be evaluating functions. So there's just some terminology that's nice to know. This g of x, that is written or read g of x. And it's not multiplication. Here the g is simply telling you what the name of your function is. Okay, so this notation here, g of 3, it means plug an x value of 3 into the expression and then simplify it. Okay, so we go to the g function. Here we are. And every time we meet an x, we're going to replace it with that value of 3. And then we just simplify the expression. So 6 minus 6 would be 0. So the output is 0 when the input is 3. G of 3 equals 0. And that is equivalent to just an ordered pair. X is 3, y is 0. The input's 3, the output is 0. Okay, let's try the next one. We go to the function g. Here we are. Input a value of 4 in for x. 6 minus 2 times 4. That would be square root of 6 minus 8, which is negative 2. And that is undefined. We're not going to be dealing with complex numbers as we look at functions. We're just looking at the real number system. So that is undefined. Okay, next one, we go to our function g, and every time we meet an x, we're going to replace it with negative 4. So we would get here 6 plus 8, so we would get 14. And remember that notation, g of 4 equals square root of 14, that is a ordered pair. X is negative 4, y is 14. Input of negative 4, output of 14. So it's not an equation here, it's an ordered pair. Okay, let's try another one. So here I need to look for an equation named f, and here it is. Okay, so f of negative 3, that means go to that function of f, copy it down, but every time you see an x, replace it with negative 3. So here we go. And now we need to simplify our expression. Okay, so 2 times 9, and then plus 9 plus 1, we would get 18 plus 10, so 28. And that is not an equation there, that's simply an ordered pair, just saying what is the output. When the input is negative 3, the output's 28. Okay, and we can input an x value of 0, that's fine. 2 times 0 squared plus, minus 3 times 0 plus 1. So this all just becomes 0 plus 1, or just 1. Okay, so you can notice here when you put an input of 0 into a quadratic that's in standard form, that output is just the constant, because all of the x's would go to 0. Now we can do this not just with numbers but also with just more expressions. So we go to our function f. Every time we meet an x, we're going to replace it with this whole expression, x plus h. Okay, so here we go. I have met an x. I'm going to replace it with x plus h. Copy the rest of my expression down. Every time I meet an x, I'm going to replace it with x plus h. Okay, so from here I needed an x plus h. From here I needed an x plus h. And everything else just gets copied. Now, remember, we don't have an equation. It looks like it, but this is simply telling us what's being asked. And now on the right side of the equation, I'm showing the work here. So I need to show that I'm going to actually square x plus h. And then distributing that 3, we would get negative 3x minus 3h plus 1. And here I would get x squared plus an xh plus another xh, so there's 2 of those, and then plus h squared minus 3x minus 3h plus 1. And then distributing my 2 to everything, I would get 2x squared plus 4xh plus 2h squared minus 3x minus 3h plus 1. and that is the output. Okay, great. So that's the idea with evaluating functions. The common mistake here is to really think of these as if they were equal equations, because you have all these equal signs, okay? But we just need to keep in mind that over here, this is showing us what's being asked of you in the problem. This is being what's asked of you, and then we have an output of 1. What's in the parentheses, inside the parentheses, that's an x value.